Good day, everyone. Hope you all are doing well. Now, welcome to our first set of videos, and we'll be looking at factoring trinomials. Now, the trinomials that we'll be factoring will be of this kind, where we have x squared plus bx plus c. All right, so let's get right into it. And we are going to start with question 1, and we're going to be looking at 1, 7, and I believe 15. All right, so let's get right into it. Now, whenever you're factoring a trinomial of the form x squared plus bx plus c, what we intend to do is to find a pure factor of c whose sum is equal to b. So for this example, let's identify what b is. So b here would be the coefficient of x, which is 7. So b is equal to 7. And in this case, c is equal to 12. All right. So what we want here is that we want two factors or a pure factor of 12 that you will add to get 7. All right. So let's list the pure factors of 12. Pure factors of 12 are 1 and 12, 2 and 6, 3 and 4. Now, additionally, we need to look at it and notice that b is a positive 7. All right. Later on, we'll look at when it is negative. So in this case, let us check our pair factors. 1 times 12 is 12. But if we add these pair, we will get 13. So this pair is not able to be used. 2 times 6 is 12. But if we add 2 and 6, we will get 8. So this one can't be used either. And let's look on the third one. 3 times 4 is 12. And when we add these two together, then our sum will be equal to b. All right. So the pair factor that we will use here for factorizing this trinomial is 3 and 7. So all we have to do here, ladies and gentlemen, is to open our parentheses. We have an x here, and then we use each of the factors in it. So we have plus 3 and another parentheses with x plus 4. Ta-da! That's it. All right. So that is what it is. That's all we need to do. All right. So for questions 1 through to 6, it's the same procedure. All right. Now let's look on question 7. In this instance, you will notice that we have a b and we also have a c. Now let's look at what our b is. Our b in this case is equal to 3, and our c is equal to negative 18. Yes, guys, it's a negative c. All right. So let's look at what we do here. Now, remember, when we're multiplying, in order to get a negative number, one of the numbers that we're multiplying must be a positive and the other must be a negative. So let's just write the factors of 18 first. All right. Let's go. So we'd have 1 and 18. All right. We would have 2 and 9. And then we'd have 3 and 6. All right. But remember now, ladies and gentlemen, these are only the positive factors of 18. If we were to have a negative 18, one of the pair or part of the pair must be a negative. All right. So let's check it. So this would be negative 1, negative 2, and negative 3. Let's look at it now. So negative 1 times 18 is equal to 18, negative 18 that is. Negative 2 times 9 is equal to negative 18. Negative 3 times 6 is equal to negative 18. Now, when you are adding a negative and a positive number, we look at the outcome. If you look at B, the outcome is 3, and 3 is a positive. So it means, therefore, that the larger numeral in this instance must be positive. All right. So in this case, if we should add a negative 1 plus 18, that would be 17. If we add negative 2 plus 9, that would be a positive 5. And if we add a negative 3 plus a positive 6, then guess what, guys? This is our winner. All right. So we have a winner here. So what we will do here is that when we look at this, this is negative, this is positive. So our factors here will be n minus 3, n plus 6. Ta-da! That's it. So remember, ladies and gentlemen, whenever you're factoring a trinomial in the form of n squared or x squared plus bx plus c, where the leading coefficient is 1, all we have to do is find a pure factor of c whose sum is equal to b. Now let's go down to question 15. All right. Let's look on question 15. Now for question 15, again, if you look on this time, you'll notice that, hey, there's something strange happening here. We have negatives and we have negatives. All right, don't worry about that. We'll take care of that. All right, so let's go. Let's identify our b in this case. And this time, I do not like the fact that our variable is b. Why? Because we have to find our b term. All right, so please do not be mistake the b that we're looking at for the variable that we're looking on. And in that instance, I'm going to change and look at question 17 instead of question 15, because the variable there in question 15 might give a misunderstanding. In this case, we are looking at k. All right, cool. So our b variable here would be negative 12. So this would be negative 12. And our c value, it would be negative 64. All right. So what we have here, ladies and gentlemen, it is that we have to find values here of 64 or factors of 64 whose sum is equal to negative 12. Again, let's list our factors of 64. All right. So let's list the factors of 64, and we're writing them in pairs as I taught you how. So we'll have 1 and 64. All right. 2. And here we go. 2 and 32. All right. We have 4 and 16. And guess what? We're just going to use these 3 pairs for now. All right. Now, in order to decide which of the factors, which of the pair must be negative, we need to look at the outcome of B. All right. Because when you're adding a negative and a positive, the numeral with this, the larger numeral determines the sign of the outcome. In this case, it is negative. So all the larger numerals must be negative. So let's go. This is negative 64, negative 32, and negative 16. All right, let's do some addition here now. So if we should say 1 minus 64, that would equal to a negative 63. That can't work. So the first pair is out. If we should do a 2 minus a 32, that would give us a negative 30. So that one would be out. All right, let's go down to the third one. If we use a 4 minus a 16, guess what, guys? This is our winner. And so the 4 minus 16 is equal to negative 12. All right. And if we multiply the 4 and the negative 16, our response will be negative 64. So let's write our factored form. So in this case, remember now our variable is not x, it's k. So it would be k, open parentheses, plus 4, close parentheses, k, and in this instance, minus 16. And that's it, ladies and gentlemen. All right. Now, we're moving down to our final example. Our final example, I believe it was, yes. Yes, awesome. So it is 21. Question 21. All right. So in this instance, if you notice, our C term is positive and our B term is negative. So what do we do with this? Let's go. Let's find out. So our B term here, ladies and gentlemen, our B here is equal to negative 11. Our C term is equal to 24. All right. Now, in this case, you might be wondering, how is it, sir, that we are going to get a negative number when we add the factors for our positive numbers? Now, I want you to remember that the outcome for a positive number when we are multiplying is either we can multiply two negative numbers to give us a positive, so a negative times negative is a positive, or a positive times a positive. So in this instance, at this point in time, because we're going to be adding those numbers, we're not interested in the positive factors of 24. All right, so we're going to list the factors of 24, but they both must be negative. So let's start with 1 and 24. Oh, we know we're going to assign the negatives afterwards. We're going to have 2 and 12. All right, so far so good. We're going to have 3 and 8. And guess what? We're going to stop right here. All right. So remember now, as I said, there are two ways that we can multiply and get a positive number. The first is by multiplying a positive times a positive. So positive 1 times 24 is equal to 24. And you can see the rest of them. 2 times 12 is equal to positive 24. 3 times 8 is equal to positive 24. But in this instance, we are not interested in the positive pair factors. We are interested in the negative pair factors. So this will be negative 1, negative 24. This will be negative 2, negative 12. This will be negative 3 and negative 8. Let's go. A negative times a positive, a negative times a negative will equal to a positive. So if we multiply a negative 1 times a negative 24, then our result will be positive 24. If we should add these numbers though, a negative 1 plus a negative 24, guess what? We will have a negative 25. And in the second instance, so we know that the first case we cannot use it, or the first pair we can't use it. Let's go to the second pair. Our second pair is negative 2 times negative 12, and that will give us a positive 24. But let's add them and see if we will get a negative 11. Negative 2 plus negative 12, that will be equal to negative 24. So again, this second value or second pair cannot be used. But let's look on our third. Negative 3 times negative 8 is equal to 24. And a negative 3 plus a negative 8 is equal to negative 11. So here we are. We found our pair that we have been searching for. We have found it. This is the winner. So let's go. We're going to write our factors now, ladies and gentlemen. And it's pretty straightforward. So we're going to have x. This time our variable is x minus 3. And then for the second factor, we're going to have x minus 8. And so, close parentheses. So, ladies and gentlemen, these are the 4 cases you will see whenever it is that you're looking on or you're factorizing a trinomial in the form x squared plus bx plus c. I hope this helped, and I hope also it clarifies some issues that you might have or you may be having. Have a good one. Take care.